If you look around you right now, there is one invention that appears almost everywhere. On cars, on bicycles, on suitcases, on office chairs. Inside countless machines that power modern industry. That invention is the wheel. The wheel is so simple that almost anyone can understand how it works. A circular object rotates around an axle, and suddenly moving heavy things becomes dramatically easier. But there is a strange question that most people have never asked. If the wheel is so simple and so incredibly effective, why did nature never invent it? Think about this for a moment. Nature has had more than 4 billion years of evolution to experiment with every possible biological design. It created eyes that can detect a single photon of light. It created bats that can hunt in complete darkness using sound. It created octopuses with astonishing intelligence and problem-solving abilities. But in the entire history of life on Earth, no animal has ever evolved a wheel. No organism moves using wheels. No biological body part functions as a true rotating wheel. And that seems incredibly strange, because if you were an engineer trying to design a machine that moves efficiently across the ground, the wheel would probably be one of the very first ideas that comes to mind. So what's going on here? Why has nature, with all of its creativity and billions of years of trial and error, never produced something as simple as a wheel? To understand this, we need to look at how evolution actually works. Evolution is not an intelligent designer sitting at a desk, carefully planning the perfect organism. Instead, evolution is a slow and messy process of trial and error. Random mutations occur. Some of those mutations help organisms survive better. Those traits get passed on to the next generation. Over millions of years, these tiny changes accumulate and eventually produce the complex living systems we see today. But this process comes with an important limitation. Evolution can only modify structures that already exist. It cannot simply redesign an organism from scratch. Imagine trying to rebuild an airplane while it's flying. You can replace small components. You can adjust certain parts, but you cannot completely dismantle the entire system and start over. And this is exactly where wheels run into their first major problem. For a wheel to work properly, it needs to rotate freely. It must spin continuously, 360 degrees, 720 degrees, and keep spinning forever. But biological bodies are not built that way. Inside every animal are systems that must remain continuously connected. There are blood vessels delivering oxygen and nutrients. There are nerves transmitting signals from the brain. There are muscles generating force and movement. All of these systems require uninterrupted connections. Now imagine a body part rotating endlessly like a wheel. Those blood vessels and nerves would quickly twist around themselves. If you have ever twisted a cable repeatedly, you know what happens. After a few rotations, the cable tightens. After more rotations, it tangles. Eventually, it breaks. The same problem would occur with any biological structure attempting to function as a freely spinning wheel. Human machines solve this problem by separating the wheel from the rest of the system. We use metal axles, we use bearings, we use lubrication to reduce friction. But living organisms cannot easily do this. Every part of a body must be nourished by blood. Every part must connect to the nervous system. A fully independent rotating structure would disrupt these essential connections. From a biological perspective, a true wheel is extremely difficult to build. But that's only the first part of the story. The second reason nature doesn't use wheels is even more interesting. Wheels are incredibly efficient, but only on smooth surfaces. Think about where wheels work best. On paved roads, on concrete floors, on flat surfaces. But nature rarely provides those conditions. Forests are filled with roots, rocks, and uneven ground. Mountains are steep and jagged. Deserts have soft sand. Swamps are covered in mud. In these environments, wheels are actually a terrible solution. A small rock can block a wheel. A hole can trap it. Soft ground can make it sink. Legs, on the other hand, are incredibly versatile. Legs can step over obstacles. They can climb rocks. They can jump across gaps. They can change direction instantly. A mountain goat can stand on ledges barely wider than its hooves. A cat can leap several times its own body length. A monkey can swing through trees with remarkable agility. If these animals had wheels instead of legs, they would not survive for very long. This leads us to a key principle of evolution. Evolution does not search for the theoretically perfect solution. It searches for solutions that work well enough in real environments. And in most natural environments, flexible legs are far more useful than wheels. But here is where the story becomes truly fascinating, because in a way, nature actually did invent something very similar to a wheel, just not at the scale you might expect. Inside certain bacteria exists an extraordinary biological machine. It is called the bacterial flagellar motor. These bacteria have a long, whip-like tail called a flagellum. This tail rotates rapidly, propelling the bacterium through liquid. What makes this system remarkable is how it works. It functions almost exactly like a microscopic rotary motor. One part remains stationary. Scientists have measured these tiny motors spinning hundreds of times per second. At the microscopic level, nature really did create something extremely close to a rotating wheel. So why does this only appear in tiny microorganisms? Why don't larger animals use this same strategy? The answer lies in scale. At microscopic sizes, a rotating structure embedded in a cell membrane can function without disrupting vital systems. But as organisms grow larger, their bodies become far more complex. They require extensive blood circulation, large nervous systems, many specialized organs. A freely spinning body part would quickly interfere with these connections. So evolution chose a different path. Instead of wheels, it developed legs, wings, fins. These systems do not rotate endlessly, but they are far more adaptable. Interestingly, when humans design robots for complex environments, we often end up copying nature. Robots built to traverse rough terrain frequently use legs instead of wheels. Climbing robots rely on articulated joints. Even exploration robots designed for other planets must combine multiple movement strategies. This reveals something surprising. Nature is not always the simplest engineer, but it is often the most adaptable one. Wheels are incredibly powerful in the world humans have built, but in the chaotic landscapes of nature, they are rarely the best choice. And that is why, after billions of years of evolution, nature never truly invented the wheel. But this observation reveals something even more fascinating. Humans and nature solve the same problems in fundamentally different ways. Nature adapts organisms to their environments. Humans reshape the environment to suit their technology. We build roads so wheels can move smoothly. We flatten land. We construct bridges. We redesign the world around us. In other words, the wheel is not just an invention. It is part of a much larger transformation. It represents a moment when a species stopped adapting to nature and instead began reshaping nature itself. And that might be the real reason wheels don't exist in the natural world. Because for wheels to truly thrive, the environment itself must change. And so far, only one species on Earth has done that: humans.